Today we're going to look at the chain rule. Once you know how to differentiate formulas like x to the power of n, or even in other levels, sin or cosine or sine of x, you start to have to differentiate more complex formulas. In mathematics, more complex functions. In mathematics, more complex functions, you obtain them by what we call composition. That sort of what I'm talking about is you have a function which is a composition of two other functions. Okay, you have to think of composition as boxes, for example. It's a good analogy. This is gx, the inner one, and then you have an fx here, which is the outer one. Okay, so you have one box inside another one, one function inside the other one. Okay, how do these boxes work? Well, if you have x and you put the g function in it, it gives gx, and then if you put it into the f box, it produces f of g of x. That's what a composition means. Okay, so it works from in to out. You first put the x into the g, it produces g of gx, and then you put the gx, the result of that, into the f, and it produces f of g of x. Okay, that's the meaning of all that mathematical language. What does the chain rule state? Chain rule allows me to differentiate those kind of functions. The chain rule says that if you have hx, which is f of g of gx, okay, the derivative of that function is the derivative of the outer part times the derivative of the inner part. You might not understand what it means like this. I'm going to use the alternate notation. We're going to use the derivative. We're going to differentiate f of g of x with respect of g of x, and then differentiate g of x with respect of x. See that here, what we're doing is, this is a normal, the one you used to, we're going to differentiate g of x with, in respect with d of x, with x. The stranger one is this part, but the only thing we're doing is, we're calculating the derivative with respect of the part inside the brackets. Okay, so just remember that if we have yx and we differentiate that between with respect to with x, we get this. Okay, but so for example, if we have y equals x squared, well, if we differentiate that, it's 2x. Okay, but that's if we differentiate y with respect to x. If we differentiate y with respect to y, it's 0 because there's no x, there's no y there. Okay, so you always have to be careful with what you're differentiating with, in respect to what you're differentiating. So there's another thing which is not mathematically true, but if you see, what we're doing is this could be cancelled out, and it's the same as differentiating. So this means differentiate that with respect to x. So if we cancel this this is h, so it would be the same thing. Okay? So, how do we really work with it? Well, what you have to remember is if we have a composition of functions, what we do is differentiate the outer part times the derivative of the inner part. Okay? Always work like that. I'll show you an example. So, before we had formulas like this, which you should already know how to differentiate. A composition might be this one. Okay? So what we're really doing is g would be x squared plus 1, which is a polynomial function, and y would be x squared. So we're doing f would be x squared. So what we're doing is we're inserting x squared plus 1 into f, and that gives you x squared plus 1 squared. Okay? So that's what we're doing there. So how would we use the chain rule here? If we want to differentiate that, I'll use proper notation. If we want to differentiate that, the chain rule says first differentiate the first part, the outer part, with respect to what is inside, okay, which basically means differentiate the outer part ignoring the x's. I'll explain. The outer part is this to the square, so how do we differentiate that? We put the index down, which is 2, x squared plus 1, and then we do 2 minus 1. So we're basically differentiating this. Ignoring, which would be, the differentiation of that would be 2x 2 minus 1. So we're doing basically the same thing, but instead of writing x, we're writing what we had inside. Okay? Is this finished? No, you always forget the last part. And the last part is we've differentiated the outer part. Now we have to go into the inner part, and that is our formula of the inner part is gx is x squared plus 1. G prime of x is 2x. Okay? Plus 0. Okay, 2x. So the chain rule says differentiate the outer part, which is done, and then differentiate the inner part, and that is 2x. Okay, so the solution of this formula would be, of this differentiation of that function would be this. Okay? Again, remember that what we've done is we've differentiated the outer part. That's the method. And then differentiated the inner part. Don't forget this part. That's the one you always forget. Okay? So we'll do another example. So we have, for example, we'll use a root. So we'll use 3x cubed plus 2x plus 1. Okay? So again, this is a composition because it's a function, and then that's the cubic root of that function. Okay? So, if we have to differentiate that, what we'll do is first the outer part, I'm going to write this, always write this in the alternate method where this is a third. So the outer part is this. We're going to differentiate that 1/3 times the same. I forget, I just write whatever is inside. And then 1/3 minus 1. Okay? And then once we've done the outer part, we have to differentiate the inner part. So times, and the inner part is 9x squared plus 2. Again, I insist, don't forget the inner part, you always forget it. This is already done, so what we have to do now is simplify and leave it in a nice, tidy notation. So that is plus 1. 1/3 minus 3/3 is minus 2/3. Again, I don't like negative indexes, so I will do 9x squared plus 2. Then that goes a 3 there, and this has gone down with 3 x cubed plus 2x plus 1, and then that, as we saw on the other chapter, which is minus 2/3, this goes down with 2/3, and if we put in the roots, that will be, that goes squared and that goes 3. Okay? If you've got troubles with how to move indices from the numerator to the denominator, or how to change them from fractions in the index to roots, you can always look at the previous lessons. Okay? So that is the chain rule. The chain rule allows me to differentiate functions which are made up of other functions, boxes in boxes. And the main thing you have to remember is differentiate the external part and then differentiate the internal part with a multiplication in between. Okay?